Then we are in Science chapter 14, Electric Current and its Effect. Today is the second part of the chapter. Yesterday, during our period, we discussed about the electric current, circuit, components, their symbols, and the cell and a battery. Today, we'll start up with the activity. Children, here you can see a circuit on your screen. If you remember, this is the same circuit which you have seen last year in your standard 6th. And when we were studying about this circuit last year, you remembered it was told that the bulb will glow only if the switch is in on position, and if the switch is in off position, the bulb will not glow. So to proceed further, we will move. Here you can see figure A. Here you can see the component in the circuit as well as a circuit with the symbols. So here this is your figure A, and here you can see that the switch is in off position. Since the switch is in off position, this bulb will not glow. Okay, and here you can see the symbol of the bulb over here. It is different, but I told you that the symbols vary in different books and in different places. This is your figure B. Here you can see the circuit is in closed condition. Okay, so here the bulb is glowing. So here you can see the bulb is glowing. Why it is glowing? Because the switch is in on position. So this is your figure A and this was your figure B. I hope, children, you can copy this electric circuit in your notebook, and I feel it will be easier for you when you are drawing a circuit using the symbols instead of using various electric components. Okay, for that reason only we are always using the symbols whenever we draw the electric circuit. Now, when you are drawing figure A and figure B and the figure components, do you found anything similar in that figure? Yes, or else do you saw that anything was similar in the diagram that was shown to you? Here it was easier to draw a circuit diagram using the symbols. Therefore, we generally represent an electric circuit by the circuit diagram. That is what I told you. We are never following the components diagram. How is the circuit diagram A and B different? Yes, I showed you both the diagrams. That is your diagram A and diagram B. This is your diagram A, and here if you go for this is your diagram B. So how are they different? Yes, both these diagrams are different because in diagram B, in figure B, the bulb was glowing. Why it was glowing? Because the switch was in on position and the circuit was closed. Whereas in figure A, the circuit was opened since the switch was in off position. Now, we will be studying about the component switch, where it can be placed, how it can be placed, and how it works. So, when we are starting with it, it can be placed anywhere in the circuit. There is no specific place for a switch to be placed in a circuit. It can be adjusted anywhere. It can be arranged anywhere within the circuit. Second, when the switch is in on position, the current from the positive terminal of the battery to the negative terminal, it flows. That means whenever we are talking of a circuit, here the current always flows from the positive terminal of the battery to the negative terminal. Okay, and then only we say the circuit is complete. So here you can see, here again you can see I have shown you in the figure two types of switch. This is in on position. okay, and this is in off position. So due to that, what is happening, this bulb is glowing and this bulb is not glowing. Now from where the current is flowing, this is the positive terminal of the bulb, of the cell. So the current is flowing from here, okay, and this is the negative terminal. So it flows from here and then it comes back to this terminal, okay. So this is how the current flows. The circuit is said to be in a closed and the current flows throughout the circuit instantly. When it flows from the positive terminal, then only we say it is a closed circuit and the current is flowing continuously. But when the switch is in off position, the circuit is incomplete. It is said to be opened since no current is flowing through the circuit. Here you can see the switch in the symbol form, the open and the closed circuit. Here you can see these are the symbols circuit for the switches. Now we will be talking of the bulb. Okay, what is a bulb and how it works. So here just now I showed you, this is the symbol that I showed you, this is the glowing bulb, okay, and this is the symbol of it, and here you can see the filament is broken over here within a bulb, okay. So such type of bulb will not glow, okay. If the filament is broken, such type of bulbs will never glow. So we will talk of it. Within a bulb, there is a thin wire which is said to be the filament, which glows when an electric current passes through it. And when the bulb gets fused, this filament is broken and it does not glow. That is what just now I showed you, that one bulb was glowing because there everything was proper and the current was flowing through it. Through that means here the current was flowing through the thin wire, okay. But in the other one, the filament was broken, so that type of bulb will never glow. Now children, you might have observed many times that when the bulb is glowing, it becomes very warm. Why it is so? Did you ever observe? I hope all of you. Okay. So the answer for the first one is yes. Why it is happening? It is because of the heating effect. It is because of the heating effect of the electric current. That means the bulb is getting heated up. The wire within the bulb, that means the filament that is there within the bulb, it gets heated up, okay, and due to that, what is happening? The bulb becomes hot. So for this again we will be doing one activity, and that activity is again given in your book as your 14.2. Children, before starting with the activity, I will just tell you, you should never touch a lighted electric bulb, okay, when it is connected to the mains, because it is very hot and there are chances that your hand may get burnt. So never try to do any experiments at that time, okay. Maybe sometimes the bulb is connected to your generator or any of the inverter or any of the other batteries, okay. So at that time also you should never try. Even there are chances sometimes that you may get an electric shock, so it will be very dangerous at that moment. So use only electric cell for whenever we are performing any of such activities at home. And at your stage, you should always perform such activities in the whenever your elders are there. Otherwise, never, you should never try them all alone, okay. So we are going to start off with activity 14.2 now. What activity it is? We will be observing the heating effect of an electric current. So what is the procedure? Make a circuit using the wire, switch, cell and a bulb. Now you will do what? First we will keep the switch in the off position and we will touch the bulb. Since the bulb will not glow because it is in off position, so it is not at all warm. Now what we will do next is we will bring the switch in the on position. Now the bulb will glow, and when it glows after some minutes, either after few minutes, now if you touch the bulb, what will be the observation? The bulb becomes very hot, indicating that the heat is produced when the current is passed through this bulb. So here if you just see on the screen, this is a glowing bulb. Now if you touch this bulb, as I said, it will be very hot. Okay. Now what is happening during the process? Basically, during this process, the electrical energy is being converted into the heat energy. This all you have already studied in 6th standard, that electrical energy get converted into many forms, that is your light energy, sound energy, heat energy. So here it is one of the form of your energy. The heat produced here depends on the amount of the resistance that is offered by the wire. That means how much energy, how much resistance we are offering to the wire of the bulb, the amount of resistance and the amount of heat, they are directly related. Copper wire, they generally do have very little resistance, so they do not get heated very quickly. But whereas the wire of tungsten or nichrome, they have very high resistance, so they get heated up very quickly. So here we are just talking of the bulb, and within the bulb, as you know, the filament of the bulb is made up of the wire of tungsten, so they are having high resistance, and since they have high resistance, they get heated up very quickly. So never try to touch the filament of the never try to touch the glowing bulb. And this is the reason why the filament of the bulb is made up of tungsten, while the nichrome wire, it is used as a heating element in our household. You might have seen your iron, your heaters that your parents are using at home, and some of the industrial heating appliances also. Okay, the geysers and all the industries, we have big machines and all. So there also we have the appliances which work on the wire which is made up of nichrome. Okay, so that we will be talking of that type of the home appliances that work on the nichrome. Either the other term that we will be using will be the element. Okay, so such appliances we will be talking of tomorrow in the period when we will be talking of the heating effect in those appliances. So I hope this much is clear about the bulb. Okay, so today during our period we have talked about two of the activities, that is activity 1.4 and activity 14.1 and activity 14.2. okay, we talked about the switch as well as we talked about the bulb. Now the question is, this is your home assignment which you will be doing, try to do it. What is the difference between an open and a closed circuit? So children, we have revised this so many times. I hope you will be able to write it down. The second one is, why copper wire is not used as a filament in the bulb? Why we are using the tungstens? Okay, so thank you. Hope so it is clear to you.